Right, for part B, it says there's a horizontal line with the equation y equals c that satisfies this differential equation. Find the value of c. So, if you look at the slope field, where do you see a horizontal line? 1, right? When y equals 1, the slope is 0 because we end up getting 1 minus 1 squared gives us 0 squared times this. It's always going to be 0. So no matter what x is, if y is 1, our slope is going to end up being 0. So this is a pretty simple one. It's just asking the value of c where this happens, and that happens when c equals 1. Alright, so that's worth 1 point. As usual, the slope field over here is worth 2 points, which leaves us 6 points for the last part. And this is the one that we see most often as one of the parts in these problems. Find the particular solution y equals f of x. So find the original equation, solve for y, to the differential equation with this initial condition. So it's going through the point 1, 0. So dy dx equals y minus 1 squared times cosine of pi x. We want to figure out what that original equation is. So our first step in doing that is separating the variables. Right? Get the y on the side with the dy, x on the side with the dx. So we're going to multiply both sides by dx. dy equals y minus 1 squared cosine of pi x dx. So the dx is over here with this x, but we also have a y here. We need to get rid of that. We're going to divide both sides by the y minus 1 squared. So we get 1 over y minus 1 squared equals cosine of pi x dx. So that's our first point here for this problem, is separating the variables. Get the, oops, I forgot the dy over here. Get the y over in here on this side with the dy. Get the x on the dx. Separated, that's worth 1 point. Once they're separated, then we can do the antiderivative of each side. And this is where half of the points come in. We get 3 points for this. But in this case, it's a little bit tougher than some of the ones we did recently. We have to use u substitution here. So on the left side, we're going to set u equal to y minus 1. So du is just going to be 1 dy. It's a really pretty simple substitution. We just end up with the antiderivative of 1 over u squared du. But instead of writing it as 1 over u squared, we can think of it as u to the negative second. On the right side, we need to set the inside here, this pi x. Instead of u, I'm going to use v, since we used u already. So I'm going to say v equals pi x. So dv, the derivative of that would be pi times dx. Means we're going to have to multiply the inside by pi, outside by 1 over pi. So we get 1 over pi times cosine of v dv. Well, antiderivative of u to the negative second, we add 1 to the exponent, and then divide by the new exponent, so we get negative u to the negative first, equals 1 over pi. Antiderivative of cosine is sine of v plus c. So we can substitute our u and v back in. This is like negative 1 over u, so we get negative 1 over y minus 1. Equals 1 over pi times sine of pi x plus c. So here's where we get some points. Antiderivative of this one's going to be 1, this antiderivative is 1, and the c is 1. So now we're up to 4 points for this problem. The next step is to figure out what c is. Remember, this is going through the point 1, 0. So we have to substitute that in order to figure out what c is. Putting 0 in for y and 1 in for x. So negative 1 divided by negative 1 just gives us 1 over here. Sine of pi is 0, so we end up getting c equal to 1. So this is just a coincidence that came out to the same as the one in part B when they were asking for a c value also. But here c equals 1. So our equation is negative 1 over y minus 1 equals 1 over pi times sine of pi x plus 1. Well, the directions ask us to solve for y. We want that particular solution y equals f of x, meaning we need to get y all by itself. And this is where we get our last point. The c was worth a point here. And then the last point is solving for y. So first thing, we need to get that y out of the denominator. So I'm going to multiply both sides by y minus 1. And then we want to get that y by itself, so we need to get rid of all of this stuff over here. So we're going to divide both sides by 1 over pi sine of pi x plus 1. And that's just going to leave us with y minus 1 on this side. So to get y by itself, I'm just going to add 1 to the other side. And that's our equation.